So we are the group 4 and we're going to discuss the acoustical control system in buildings. Fundamentals of sound. Acoustic. The science of sound, including the generation, transmission, and effects of sound waves. So in this chapter, I will introduce the elements of acoustical design. So ginagamit ito para mabawasan yung ingay or maging maganda yung sound sa isang building. The human ear. The human ear converts sound's energy to mechanical energy, to a nerve impulse that is transmitted to the brain. It allows us to perceive the pitch of sound by detection of the wave's frequency, the loudness of sound by detection of wave's amplitude, and the resonance of the sound by the detection of the various frequencies that make up a complex sound wave. So, our ear allows us na marinig natin yung different types of sound. And because of the frequency na nalalaman natin kung malakas ba or mahina o kaya mataas or mababa yung sound na naririnig natin. The human ear consists of three fundamental parts: the outer ear, middle ear, and inner ear. Outer ear. The outer ear collects and channel the incoming pressure wave that make up sound through the ear canal. So, yung outer ear is consists of an ear laugh and an approximately 2 cm ear canal. Yung outer ear is nagsisilbing channel for the sound wave papunta sa ear canal hanggang sa makarating sa middle ear na nagiging dahilan para marinig natin yung sound. Middle ear. The middle ear is an air-filled cavity that consists of an eardrum and three tiny interconnected bones. So, yung three tiny interconnected bones is the hammer, anvil, and stirrup. It acts as the lever to amplify the vibration of sound waves. Yung eardrum, ang receiver ng mga sound waves. So, inner ear. The inner ear is a fluid-filled spiral shell with groups of the delicate hair sensor on the membrane that responds to different frequencies transmitted down the spiral. So, the fluid-filled spiral shell is tinatawag din na cochlea. It can stretch to approximately 3 cm. Yung inner surface ng cochlea is lined with over 20,000 hair-like nerve cells that perform the most critical role in our ability to hear. Sound. Sound is defined as a rapidly varying pressure wave with a fluid medium such as air or water that is capable of being detected by the human ear. So, nabubuo yung sound kapag nagsasalita tayo kasi nagbabibrate yung vocal cord natin. Nagiging reason para mag-create ng sound waves or oscillation in air pressure papunta sa tenga ng taong nakakarinig sa'yo. Sound frequency is a number of sound wave crests per unit time that pass a fixed location. The wavelength or distance between wave crests is related to frequency. Lower frequency have longer wavelengths. So, sound frequency is also measure of tone and pitch of sound. Pag higher frequency sound, meaning yung mga waves is dikit-dikit, and kapag lower frequency sound, yung mga waves is hiwa-hiwalay. Sound that is audible by a human ear is in a frequency range of 20 and 20,000 Hz. Pero yung pandinig natin or yung tenga natin is sensitive na siya from the sound of 1,000 to 5,000 Hz. Frequencies of common sound. So, common sound. Female voice range is from 600 to 800 Hz. Fluorescent picture humming sound range from 500 to 650 Hz. And yung human ear nga natin is nag-span siya from 20 to 20,000 Hz. Intensity of sound. The decibel is a measure of the intensity of sound. The decibel scale run from the faintest sound the human ear can detect, which is labeled 0 decibel to over 180 decibel. Yung decibel is a logarithmic unit na ginagamit para masukat yung level of sound. A logarithmic scale is based on power or multiples of 10. Ibig sabihin, mag-i-increase yung decibel intensity ng 10 units 10 times the lower value. So, in this chart, pinapakita dito yung different level of sound. Halimbawa, yung 40 decibel pababa is considered as quiet, while 70 decibel pataas is considered as loud or maingay or masakit sa tenga. A bell is another unit for comparing intensities of sound. 1 bell equals 10 decibel. Sound intensity falls on the bell scale from 0 bell o yung maganda pa rin sa pandinig to 13 decibel o yung masakit na siya sa tenga. The origin of decibel is the bell, which was used to express the transmission losses of long telephone lines. It is named for Alexander Graham Bell. Note that one is omitted from the name of the unit. Yung bell kasi is masyado siyang malaki for practical use, kaya pinalitan siya into decibel. Yung ibang air conditioning manufacturers, ginagamit pa rin nila yung unit na bell in sound rating for their product. For example, 7.6 bells yung standard air conditioner sound performance, and yung 7.2 bells is yung pinakamababa or very quiet sound. And yung 7.8 is usually unacceptable kasi masakit na siya sa tenga or masyadong maingay. Loudness in the human ear. In the human perception of the strength of a sound, the perceived loudness of noise does not necessarily correlate with its sound intensity level. Apparent change in loudness varies greatly with actual change in sound level. For example, pag yung sound is nag-shift into 1 decibel, di natin siya ganong naririnig, and yung 5 decibel pataas is noticeable na or malakas na yung sound na maririnig natin. The A-weight decibel is measured of sound intensity level that is adjusted to match the acuity of the human ear, which does not respond equally to all sound frequencies. So, meron ding B-weight and C-weight, pero hindi siya ganong ginagamit. The human ear has a tendency to magnify sound having frequencies in the range from 1,000 to 5,000 Hz. So, yung sound na yan is masyado nang malakas para sa pandinig natin. Yung mga sound outside this range is humihina siya by using electronic filter. Yung sound level yung magre-read ng mga numerical value na sakto lang sa pandinig natin. Behavior of sound. Sound moves in a straight line path unless it is interrupted. When sound waves strike an object, they can be reflected, absorbed, or transmitted. Reflection and absorption are dependent on the wavelength of the sound. The percentage of the sound transmitted through an obstacle depends on how much sound is reflected and how much is absorbed. High-frequency sound, there is a chance na tumago siya sa mga thin materials and curb, and also sa mga barriers. Yung low-frequency sound naman is mas madali siyang nagre-reflect sa mga thin materials and hindi siya nag-bend sa mga barriers. Ibig sabihin, mas mahirap na i-isolate yung high-frequency sound. The formula for the speed of sound in air in feet per second is as follows, where T is in degrees Fahrenheit. C is equal to 49 times square root of 460 plus T. And in IS metric unit, the formula for the speed of sound is C is equal to 20 times square root of 273 plus T.
So, ang report ko po ay about noise. Noise is any disagreeable or undesirable sound. Ito daw yung ingay na nakakaabala sa ating pagpapahinga, sa sleep natin, sa mental concentration, or sa speech communication. In simple word, noise is a sound that is not part of what a person is trying to hear. Ito yung ingay na hindi kasama kung ano dapat yung naririnig ng isang tao. Ambient noise. Ambient noise is the all-exclusive noise associated with a given environment. It is usually a composite of sound from many sources and from many directions in which no particular sound is dominant. So, sabi dito, ito daw yung tunog kung saan ay wala siyang particular na pinanggagalingan, kung saan hindi mo alam kung saan nagmumula ito, pero ma-identify mo kung anong klaseng tunog to. Sabi nga dito, given environment. So, mga environmental sounds like yung animals, waves, rains, winds, yung mga tunog na nagmumula sa environment, yun yung tinatawag natin na ambient noise. So, when we say background noise, it is the total noise from all sources other than a particular sound that is of interest. So, sabi naman dito, ito daw yung ingay na hindi mo gustong marinig pero naririnig mo. Halimbawa, gusto mong makinig ng music. Then may mga kasama ka na mga nag-uusap, nagkukwentuhan, yun yung tinatawag natin na background noise. Kung saan, hindi yun yung direct sound na gusto mong marinig, kundi yung music na dapat papakinggan mo, pero naririnig mo rin yung mga nasa paligid mo. Yun yung tinatawag na background noise. White noise. White noise is undistinguishable background noise. So, when we say undistinguishable, ito yung sound na hindi natin na-detect kung saan kung anong klaseng tunog siya, pero na-detect natin kung saan siya nanggagaling. Kadalasan sa mga white noise, ito yung mga regular technology na ginagamit natin sa paligid natin. Mga common technology like electric fan, aircon, yung mga tunog na yun, alam natin na sa electric fan pero hindi natin ma-identify kung anong klaseng tunog siya. Yan yung tinatawag na white noise. Halos kaparehas lang din siya ng background noise. Ang kaibahan lang, yung background noise, yung total lahat ng sound na naririnig natin kumpara sa direct sound na gusto nating marinig. Kasama dito yung usapan ng mga tao, yung pagtunog ng mga animals, yung mga technology, lahat yon background noise. White noise, about lang sa regular technology o yung mga alam natin kung anong tunog to, alam natin kung saan nanggagaling to, pero hindi natin alam kung anong tunog yon. Yun yung white noise. Exposure to excessive noise. Unprotected exposure to sound pressure levels above 100 dBA will cause permanent hearing loss. Hearing protection should be used when exposed to noise levels above 85 dBA. About the sound of a lawn mower when it is being pushed over a grassy surface, especially when prolonged exposure more than a fraction of an hour is anticipated. So, paano nga ba kapag na-expose tayo sa excessive noise? Pag sinabi nating excessive noise, ito yung more than normal or more than usual na kailangan or dapat lang nating marinig. Sabi, unprotected exposure to sound pressure levels above 100 dBA will cause permanent hearing loss. So, kapag daw na-expose ka sa 100 dBA, when we say dBA, weighted decibels, magkakos na siya ng permanent hearing loss. Hindi ka na makakarinig or mabibingi ka na. Ang normal lang kasi na decibels na kailangan or dapat matik ng tenga natin is about 60 decibel. Kung saan, ito yung tunog lang na kasing lakas kapag nakikipag-usap ka sa kapwa mo. Then, pwede naman magtaas to sa 70 decibel kung saan sa mga trabaho, sa mga labas dyan na nagsasama-sama yung mga tunog, pwede pa yon 70 decibel. Pero wag continuous yung pagtitake mo ng ganong tunog kasi pwede rin yung mag-cause ng harm sa tenga mo. Meron din tayong tinatawag na 80 to 89 decibel na na-take natin. Kadalasan ito sa mga heavy traffic kung saan halo-halo yung mga sound, mga tunog na naririnig natin na hindi na tama na dapat nating matake. Kasi nga, hanggang 85 pababa lang yung kaya nang i-take ng tenga natin na sound. Kapag lumagpas na sa 85 pataas decibels, yung natitake natin, naririnig natin, magkakos na siya ng hearing loss. Unti-unti nang mabibingi tayo, hindi na tayo makakarinig. Yun yung pag na-expose tayo sa excessive noise. Damage to hearing from loud noise is cumulative and irreversible. So kapag daw na-damage na yung tenga natin sa tuloy-tuloy na pag-take natin ng sound na higit sa normal, at yung damage na na-take natin doon, lalo, tapos kapag lumala na siya, hindi na siya magiging okay. Kasi kapag na-expose pa tayo dun sa mga high noise level, pwede rin siyang mag-cause ng tinnitus or tinnitus. Ito yung sakit kung saan parang may naririnig ka dun sa may ulo mo na tumutunog, nagri-ring-ring na ganon. Nakakala mo kung ano yun, pero hindi yun naririnig ng iba. Ikaw lang nakakarinig dun. Yun yung kapag na-expose ka masyado dun sa excessive noise. So, next is noise dose. Noise dose is the exposure to noise expressed as a percentage of the allowable daily exposure. When we say noise dose, ito yung measure ng isang ingay or tinatawag natin na decimeter. Ito rin yung total sound ng exposure na non-normalized to an 8-hour working day. Next is reverberant sound. Pag sinabi nating reverberant sound, ito yung causes of numerous reflection of the sound. Ito rin yung parang nagkakause siya ng echo pero hindi siya echo. Parang ganun lang. Kasi dito sa reverberant sound, maraming beses siyang pwedeng marinig and then maririnig mo lang siya after 0.01 to 0.20 second. Kadalasan yung sound wave sa room, typically nagta-travel siya ng about 1,130 feet per second multiplied by 345 meter per second. So, parang delay yung maririnig mo kapag na-sound na ito. Sound waves from a sound source can take direct path to a listener's ear or can reflect off surfaces before being heard. So, sabi, bago mo daw marinig to, yung sound wave na manggagaling dito ay hindi direct na dediretso sa'yo kasi may mga gamit pa dyan ay meron pang mga bagay sa loob ng room like walls, ceiling, or floor surfaces. So, dun muna magre-reflect yung mga sound bago mo to marinig. So, madidelay siya ng mga ilang seconds. Or ilang seconds, tama. The reflected sound waves arrive at the listener slightly later than direct sound because they travel a longer distance to the ear. So, yun nga, sinabi, di ba? Na, maririnig mo siya later than direct sound. Parang, medyo matagal bago mo siya marinig. Like, sinabi ko ngayon, or may tumunog, pero narinig ko siya, makalipas ang ilang segundo. Ganon. Reflected sound is generally weaker because only a fraction of the direct sound is reflected as the receiving surfaces will absorb some of the sound energy received. Reflected sound is noticeable by the listener within about 0.5 seconds after the arrival of the direct sound. A series of fairly distinct reflections from various reflecting surfaces known as the early reflection reach the listener. So, sabi dito, kapag daw yung reflected sound ay naulit, malalaman yon ng listener. Manonotice siya ng isang listener or kung sino man yung makakarinig dito. Kasi within about 0.5 seconds after nung arrival ng direct sound, yung series of fairly distinct reflection from various ay magre-reflect siya sa mga surfaces. Ito yung tinatawag na early reflection. Yung early reflection na to ay within 0.5 seconds or tumama na sa ibang bagay na nasa room katulad ng mga walls, ganun. Then pag dumating na dun sa listener, ito yung matatawag natin na early reflection. Ganun. They typically arrive from the nearest side wall or from the ceiling for listeners in the center of the space. They tend to reinforce the direct sound. After about 0.5 seconds, additional reflection merge into what are called successive reflection. So, ibig sabihin, yung noise, mag-a-arrive siya hindi dun mismo agad sa listener, kundi typically mag-a-arrive siya dun sa pinakamalapit na side wall or from the ceiling bago dun sa may listener na nasa center ng space. Kadalasan, they tend to reinforce the direct sound. For about 0.5 seconds, mag-a-add siya ng reflection na mag-merge into what are called successive reflection. So, reverberant sound referred to as reverberation. When we say reverberation, ito nga yung numerous reflection of a sound. And it is made up of successive reflection from the surfaces in an enclosed space. After the direct sound has ceased, when sound is produced in a space, a large number of reverberation builds up and then slowly decay as the sound energy is absorbed by the walls and the air. So, sabi, kapag daw na-produce na natin yung sound na yon sa isang space or sa isang room, yung large number daw ng reverberation ay mabubuo, then slowly, parang babagal ganon na makarating dun sa pinaka-listener mismo kasi mag-a-absorb pa yung ma-absorb ng walls or mga ceiling or kung saan man dadaan yung sounds na yun, yung sounds energy na yun, ma-absorb pa siya ng mga walls and air. Kaya medyo mas matagal kumpara dun sa bago marinig ng isang listener. Reverberation accompanies any sound emerged in an enclosed environment. Reverberation is most noticeable when the sound source rapidly stops, but the reflection continue, decreasing in intensity until they can no longer be heard. Reverberation is an enclosed space dies away with time as the sound energy is absorbed by recurring interaction with the surfaces of the room. So, sabi naman dito, kapag daw nakasama or nagkaroon ng accompany yung sound at na-emerge ito dun sa reverberation, ay magkakaroon sila ng emerge in an enclosed environment. Kasi yung reverberation, ito yung most noticeable when the sound is rapidly stopped. Pero yung halimbawa, yung reverberation, nag-stop na yung sounds na nanggagaling sa kanya. Pero yung reflection niya, continue pa rin yung tunog at maririnig yung ibang listener kung sino man makakarinig nun. Then, magdi-decrease siya ng intensity hanggang sa hindi na siya marinig. Reverberation kasi is an enclosed space dies away with time as the sound energy is absorbed by recurring interaction with surfaces of the room. So, habang tumatagal, kunwari wala nang nilalabas na sound, pero yung sound na yon mauulit-ulit pa ulit na marinig hanggang sa mawala yon sa loob ng isang or sa surface ng isang room. So, last is, reverberant sound is a different than an echo or a series of echoes. An echo is a distinct, delayed reflection of the direct sound with a delay more than 0.1 seconds. So, magkaiba daw sila ng echo. Though may pagkakapareha sila dun sa part na inuulit-ulit yung sound. Pero kasi yung reverberant sound, parang sa kanya lang nanggagaling yung echo. Kapag sinabi kasi nating reverberant sound, mauulit-ulit yung sound na nanggagaling sa isang bagay hanggang sa mawala ito. Kahit na mag-stop yung paglalabas niya, maririnig pa rin yung sound neto. Unlike dun sa echo na kapag narinig mo nang minsan, then nag-stop na rin kung saan nanggagaling to, mag-i-stop na rin yung tunog niya. Sabi pa dito, an echo is distinct. So, nadidelay siya ng 0.1 seconds. While dun sa reverberation, nadidelay siya ng 0.5 seconds. And sabi pa, a reverberation is perceived when the reflected sound wave reaches an ear in less than 0.1 seconds after the original sound wave. Because of the short delay, humans do not completely discern each reflection as a production of original sound but do hear the effect of the entire series of the reflected sound waves mix. So, dahil daw nga dun sa short delay na yon, yung mga tao daw, yung mga listener, hindi nila completely ma-identify yung isang reflection or mga reflection as a reproduction ng original sounds. Kasi yung effect nun sa tenga ay mananatili na lang o magre-reflect na lang siya as a entire series of a sound waves.
So, ang report ko naman po ay about reverberation time. Nabanggit po ng unang reporter ng reverberation ay causes ng paulit-ulit na reflection ng sound. Ngayon naman po ay about sa reverberation time, kung saan ang ibig sabihin po nito ay yung oras na kailangan for the sound to fade away or yung decay nito sa isang closed space. Reverberation time is the time required for the reflections of direct sound intensity. When we say RT60, it is the commonly used abbreviation for the reverberation time. Then, ito rin yung nagme-measure kung gaano ba katagal or how long it would take a sound to decay 60 decibels in a large room. Then, over 100 years ago, si Wallace Savin, isang physics professor sa Harvard, ay nakadevelop ng isang formula na tinatawag ngayong Savin's Formula. Sa Savin's Formula, yung reverberation time ay nakabase sa room volume or V in feet cube or meters cube sa formula. Then yung individual surface area of each material in the room is S in feet cube or meter squared. Yung absorption coefficient naman ay sa bawat individual surface at a specific frequency. May constant din na 0.049 na maaaring palitan ng 0.16 para sa metric analysis. So, ito po yung formula niya. RT60 is equal to 0.049. Ayan. So, kaya hanggang S3 siya kasi depende sa given na absorption coefficients pero continuous lang din yung formula. So, absorption coefficients represent the fractions of sound energy. Yung absorption coefficient daw, sa formula, ito yung nag-represent sa fraction of sound energy, hindi yung level ng decibels. Then, yung material ay ma-absorb as a decimal from 0 to 1. And, madedetermine ito through laboratory measurements. Pinaliwanag din sa reverberation time na nakadalasan daw ay kinakalculate siya sa room ng unoccupied. Kasi kapag may tao doon or bagay, may iba yung calculate. Kasi yung suot ng mga tao, nagbibigay siya ng additional sound absorption at sinasabing unoccupied room ay ang worst scenario kahit na unreasonable as occupancy varies. So, optimum reverberation times. Yung optimum reverberation time ay pinaka-desirable na reverberation time para sa specific room volume at room type kagaya ng auditorium, church, sanctuary at classroom, kung saan gumagamit ng speech versus music and sound frequency. At sa isang large and enclosed spaces ay masasabi na yung reverberation time is long at talagang malinaw mo na maririnig yung sound na umiikot sa paligid katulad ng mga lugar gaya ng gymnasium, indoor swimming pools at cathedrals. So, if the reverberation time is excessive, it makes the reflected sound run together, creating garbled sound. So, kapag naman ang reverberation time ay sobrang makagawa ng reflected sounds na nag-run together at na nakakalikha ito ng mga tunog na hindi natin maintindihan o maunawaan. Yung room daw na para sa mga nag-speech ay kailangan na mas maikling reverberation time kaysa sa music. Dahil kapag mahaba ang time ng reverberation sa speech ay mahihirapan itong maintindihan ng mga nakikinig. And if the reverberation time from the syllable to syllable overlaps, mas mahirap maintindihan yung mga salita dito. Next. Reverberation time is primarily controlled by change the reflectivity. So, nakokontrol ng reflectivity yung reverberation time. Yung reflectivity ay tinatawag nating absorption coefficient dun sa surface na isang space. and it possible adjusting the size of the space. So, the absorption coefficients of the surface of the room determine how much sound energy is lost in each reflection. Highly reflective materials. Low absorption coefficients will increase the reverberation time, while absorptive materials reduce the reverberation time. So, yung absorption coefficients ng surface ng room ay nade-determine kung gaanong sound energy yung nawala or nabawa sa bawat reflection. Kapag highly reflective materials at mababa yung absorption coefficient, ay tataas yung reverberation time. While yung absorptive materials naman na mababa din yung absorption coefficient, ay bababa o mababawasan yung reverberation time. Similarly, people and furnishings absorb energy, reducing the reverberation time. Additionally, yung mga large spacious spaces ay nagtetend ng mayroong longer reverberation time kasi yung sound waves. Nagta-travel siya sa long distance between reflections. And yung designer ay kaya niyang i-increase yung reverberation time sa pag-increase din ng volume sa space ng isang room. Halimbawa, dito yung taas ng ceiling ng isang room. Next topic is vibration. It said that it is the oscillating movement of the body. So kapag daw nag-move yung katawan natin, back and forth, at hindi ito naalis sa pwesto kung nasaan man ito, yun yung tinatawag natin na vibration. Vibration can cause unwanted noise. Halimbawa, nasa isang building ka, katabi ng building ay yung daan ng train. At kapag dumaan ng train, magkakos yun ng vibration. Another example is kapag gumagamit ka ng washing machine, dryer, or unbalanced electric fan. So, vibration can be reduced with vibration insulators, a system of connected springs and masses for damping. The concept of vibration isolation is demonstrated with a weight suspended from a rubber band. So, sound may be transmitted through the air or through the structure. So, ito naman yung pagtatransmit nga daw ng sound sa isang building through air or through structure. So, airborne sound. Ito yung mga tunog na sumasama sa hangin. Halimbawa, yung music or speech. Sasama siya through air, tapos kapag bumangga siya sa wall or any something solid, yung collisions mag-send ng vibration dun sa wall. Yung structure-borne sound naman, natatransmit siya through construction assembly. Halimbawa, sa isang building, yung mga footsteps na nagaganap or sa upper floor, pwede siyang magka-effect ng vibration sa lower floor. Basta about the structure, dito papasok yung sa wall, floor, or ceiling. Planning is required to reduce the transmission of sound. So, yun nga daw, kailangan ng plano sa transmission ng sound mula sa exterior at interior and from room to room. Basically, in each space, it is necessary to keep the necessary sounds in the undesirable sounds out. So, sound is not selective. It passes through most building materials and any openings, no matter how small. As sound passes through building materials, it is intensity reduced. The use of sound absorbent materials on walls, ceilings, and floor will increase the transmission of sound through the surface. That is, will make the room in which the sound originates quieter, but part of the sound will travel through the surroundings of room. Construction noise. So, when we say construction noise, ito yung mga ingay or tunog na maririnig natin sa isang construction site. Gumagamit sila ng mga mechanical tools dito. At isa ito sa dahilan minsan kung bakit nakakaabala sila sa mga nearby businesses or residents. Yung mga noise or sound na nagagawa ng construction noise ay kadalasan umaabot sa lakas ng 80 decibels sa umaga at 70 decibels naman sa gabi.
going to report sound ratings. Sound control is an important consideration in the design of the project. The design of the building must ensure that all spaces will be insulated from unreasonable outside sources of noise. Sounds within a special mask will also be controlled. So, yung sound control isa to sa pumipigil para mapigilan yung unreasonable sources of noise sa paggawa ng project or sa pagde-design ng building. Dapat ma-ensure lahat ng spaces matakpan kumbaga para wala siyang unreasonable noise na maririnig. The sound isolation between rooms and floor levels and noise reduction within a room as measured by several single number rating system. The single number rating offers an engineering measure or performance between wall, ceiling, and floor assemblies within the space. So yun nga. Transmission isolation ratings. Sound tracing system that evaluates the transmission of sounds through a construction assembly. Example, partition, wall, ceiling, and floor as to be follow. Yun yung mga may partition sa sounds, yung tulad nga ng walls, ceiling, and floors na harang din yung sounds. So, next, sound transmission class. The sound transmission class or STC is a single number rating system that rates the ability of a wall or others construction to block sound transmission. It is used to compare the airborne sound isolating characteristic of construction assemblies used to separate occupied spaces. The STE value can be determined through the testing of the assembly in the field, in which case the reported value is referred as the Field Sound Transmission Class or FSTC. So ngayon, sa ngayon sa mga sound transmission ay may tinatawag na STC. Yun yung ngayon may sukat yung mga sounds no, at doon mo malalaman yung mga airborne sounds isolating the characteristic of construction. Yan, doon.
Good day everyone, I'm Charmaine Diane Reyes and I will be reporting impact ratings. So to begin, an impact sound is produced by the collisions of two solid objects. So napoproduce daw yung impact sound sa pag-collide. Pag sinabi natin collide, ay yun yung pagbabanggaan ng dalawang object or ng dalawang solid objects. So sa building, napoproduce yun sa yung footsteps, sa mga objects na nahuhulog, na tumatama dun sa mga interior surface, katulad nun sa wall, floor, or sa ceiling. Impact sound ratings include the following. Impact insulation class. The impact insulation class or IIC is a number rating based on standardized test performance for evaluating the effectiveness of assemblies in isolating impact sound transmission. So yung ICC is an acoustic rating na ginagamit para ma-quantify yung impact ng sound absorption and vibration isolation. So ito ginagamit to sa mga floor at saka sa ceiling assemblies. So sinasabi na the higher the rating, the better the assembly, reducing impact noise transmission. The IIC is the current rating system used to rate the ability of floor ceiling assemblies to resist the transmission of impact sound. So sa mga building, halimbawa sa mga sa room, meron silang ginagamit na instrument para ma-rate nila or malaman nila yung IIC. So next is yung impact noise rating. The impact noise rating or INR is an obsolete rating system that rates the ability of floor ceiling assemblies to resist the transmissions of impact sound. So ito yung ginagamit na rating system para malaman or ma-rate natin yung kakayahan ng isang floor ceiling para mabawasan yung pag-transmit ng impact sound. So, ratings are based on plus and minus ratings from a standard curve. So, sinasabi na kapag plus rating, ini-indicate na better than standard performance. And kapag naman minus rating, ini-indicate na less than the standard performance. So, next is absorption ratings. Sound absorption is a property of materials that causes a reduction in the amount of sound reflected from a surface. High absorbing surface in a room will reduce sound intensity in that room by not reflecting all the sound energy striking the room's surfaces. So, yung absorption ratings, ito is the measure of the amount of energy removed from the sound wave passes through a given thickness of material. So, common absorption ratings are the following. Absorption coefficient. The absorption coefficient is a measure of the sound absorbing ability of a surface. So, absorption coefficient determines how far into a material light of a particular wavelength can penetrate before it is absorbed. So, sa mga material, kapag may low absorption coefficient, light is only poorly absorbed. And kapag naman yung material is thin enough, mag-appear lang siyang transparent dun sa wavelength. And yung yung absorption coefficient is depende sa materials and also yung wavelengths of light which is being absorbed.
Hello classmates, I am Annalisa M. Pascual and my topic for today is noise reduction coefficient. The noise reduction coefficient or NRC is also used to measure the ability of a material to absorb sound rather than reflect it. The material absorbs part of the sound striking the surface of the material and part of it is transmitted through the other side of the material. The NRC is established by averaging the absorption coefficient of the middle frequencies, expressed to the nearest multiple of 0.05. It can theoretically range from 0.0 to 1.0, with a perfectly reflective material rated at 1. If a material has an absorption rating of 0.25, the material will absorb 25% of any sound that strikes it and will reflect the remaining 75% of the sound. A difference of 0.10 in the NRC rating is seldom detectable in a completed installation. NRCs for selected materials and finishes are provided in Table 23.12. The recommended NRC for surfaces in most rooms is between 0.6 and 0.75. Special consideration should be given to computer and accounting rooms, classroom, kitchens, and any room where excessive noise is generated. Next is Ceiling Attenuation Class. The Ceiling Attenuation Class or CAC, previously referred to as the Ceiling Sound Transmission Class or CSTC, rates a ceiling's efficiency as a barrier to airborne sound transmission between adjacent closed offices. The CAC is a single number rating. An acoustical unit with a high CAC may have a low NRC. Next is equipment noise. Noise from rooftop or mechanical room equipment can affect both occupants inside a building and nearby property owners. Typically, a building specification will require the mechanical equipment noise be less than a specific level in occupied areas of the building based upon the following ratings. Room criteria. The room criteria or RC are a single number noise rating system used to diagnose the rate the HVAC noise exposure in a room. RC ratings contain both a numerical value and a letter rating related to sound quality. The RC numerical rating is simply the arithmetic average of the sound pressure level in the 500, 1000, and 2000 Hz octave bands, which is the speech interference level, or SIL. These SIL frequencies affect speech communication privacy and impairment. Studies show that an RC between 35 and 45 will usually provide speech privacy in open-plan offices, while a value below 35 does not. Above RC 45, the sound is likely to interfere with speech communication. The four-letter designation currently in use are rumble, hiss, acoustically induced vibration, and neutral. These letters are determined by analyzing the low and high frequency sound introduced into the room. A typical specified value in private offices is RC35N. An RC25N to RC30N is desirable in classrooms and lecture halls. A much higher RC50 value is acceptable in kitchens, shops, gymnasiums, and warehouses where noise is less of a concern. This RC rating is more effective than the NC system. It does a better job in rating noise with strong low-frequency content. Noise criteria. The noise criteria, or NC, is a single-number noise rating system used to rate continuous noise in a room from all types of HVAC equipment. HVAC air terminal products are commonly specified and reported in NC rather than RC. NC ratings have been common in specifications for a number of years, with the most common requirements being between NC 30 through 45. Although NC offers a great improvement over previous single-number ratings, it gives little indication of the quality of the sound. A typical NC rating for classrooms, private offices, and conference rooms is NC30. In a gymnasium where a higher noise level is more tolerable, a typical rating is NC45.
Acoustical design and building. Included in this section is a discussion of various architectural and construction elements that must be considered to effectively control sound. Some of these elements fall outside of the designer's principal area of concern and responsibility, but the designer should be aware of them and be certain that they are not overlooked. Generally, the designer would consider the following elements: surrounding environment, arrangement and layout of rooms, shape of rooms, reflecting surface, isolation of vibration, isolation of impact, isolation of sound, background noise. Building acoustic, it is the science of controlling noise in buildings. Surrounding environment. The surrounding environment should be carefully reviewed before a building site is actually purchased, and once purchased, before planning room arrangement and wall materials. In addition, the zoning should be carefully checked to determine what types of business might move into the surrounding area. The location for a building should be chosen with the use of the building in mind. Dapat yung surrounding ng isang site bago or once na nabili na, i-check natin mabuti. Once na nabili na yung building site, yung mga ingay na galing sa labas ay pwede ma-reduce sa pag-aayos ng building site. Yung ibang technique naman sa pag-reduce ng noise sa building ay yung paglalagay ng barrier wall or ibang building din. Yung ginagamit na barrier. Pwede ding mga puno, pero dapat yung mga barrier na gagamitin is malapit dapat sa source ng noise. Ito yung example ng barrier wall. Arrangement and layout of rooms. Noisy rooms should be separated from quiet rooms by as great a distance as possible. The building layout should be designed so that the rooms that are not susceptible to noise, for example, is closet and corridors, acts as a buffer between those areas that contain noise sources and that those require quiet. The rooms from which the noise will originate should be located wherever the noise from exterior source may be expected. Yung mga room na kailangan tahimik, dapat malayo or nakahiwalay sa room na pwedeng maging source ng ingay. And yung layout dapat nakadesign na hindi mabilis kapitan or malusutan ng noise. Dito sa example sa reference book natin sa plano ng apartment na to, makikita natin na medyo nakalayo yung bedroom na kailangan tahimik lang sa lugar na pwedeng maging source ng ingay sa loob, and nakamirror siya, so yung noise level ay equal lang. Sa next figure naman, makikita natin na ginamit yung closet at storage as a noise buffer sa mga rooms. Shape of rooms. The room proportion used will affect the sound reflection within the space. Room shapes to be avoided are long, narrow rooms, or corridor with high ceilings, and rooms that are nearly cubical. Each of these room proportion will cause excessive reverberation or sound reflection or echoing. Yung mga rooms na mahaba, makitid, at mga corridors na may mataas na ceiling ay yung mga dapat iwasan nating design, kasi yung mga room na to ay nagkakos ng masyadong pag-echo.
Hello, my name is Ella May M. Cartagena and I'm here to report focusing surfaces, isolation of vibration, and isolation of impact. So first, let's discuss focusing surfaces. Reflected sound waves can be focused intentionally or inadvertently. A flat surface, i.e. a wall, reflects sounds better than an irregular surface, which tends to break up sound waves. Reflection from large concave surfaces also focuses sounds. Sounds near the focus of a curved surface may be heard too loudly in auditoriums, theaters, church sanctuaries, and classrooms. Sound is more pleasing if it is evenly dispersed, with no prominent echoes, no significant dead spots or live spots. This even dispersion is usually achieved by avoiding any focusing surfaces and avoiding large flat areas that reflect sound. So, yun nga, yung isang patag na surface or pader ay sumasalamin ng tunog na mas mahusay kaysa sa hindi regular na surface. May possibility kasi na masira yung mga sound waves. So, pag ang sounds ay malapit sa isang curved surface, maaaring mas marinig siya ng mas malakas sa mga auditorium, yun nga example, sa mga church sanctuaries, and etc. So, mas maganda or mas magiging kaaya-aya yung magiging tunog kung magiging evenly dispersed or walang mga echo. Sound into the listening area. So, rough walls tends to diffuse sounds reflecting in a variety of direction. This allows us spectator to perceive sounds from every part of the room, making it seems lively and full. For this reason, auditorium and concert hall designers prefer construction materials that are rough rather than smooth. Some it is desirable to add some anti-focusing surfaces or devices called acoustical baffles and banners, which are used to absorb reflected noise bouncing off reflective walls, floors, or ceiling. So, yung mga magaspang naman na pader ay may possibilities na mas makalat yung tunog nila kasi sumasalamin sila sa iba't ibang mga direction. So, yung iba naman ang gusto nila mag-add ng anti-focusing surface o yung tinatawag nga natin na acoustical baffle and banners para mas ma-absorb nila yung noise and na magre-reflect sa walls tsaka sa mga floors. So, next is isolation of vibration. Because the structural elements of the building readily transmit sounds throughout the building, noisy or vibrating equipment should not be attached to the structure. Equipment within the building such as heating units, pumps, and motors should be mounted on commercially available resilient machinery mounts and bays. Soft resilient subfloors materials are often used under the wearing surface of the floor and under the equipment to reduce the transfer of vibration from the equipment to the structure. Equipment located in the basement of a building may be placed on resilient mounts and the concrete pad that is isolated by expansion joints from the rest of the floor.
this is an example of discontinuous construction which is very effective when it can be used. So, what is vibration? So, yung vibration, it is unwanted motion that is transmitted to the building structure and occupants generally from rotating HVAC equipment. So, napoproduce yung sound when an object vibrate. So, hindi na daw dapat na nakasabit sa structure yung mga kagamitan sa loob ng gusali like yung heating units nga, yung pumps and motors. Dapat sila, na-mount sila sa mga commercially available resilient machinery. So, yung sub-resilient subfloor materials, sila yung madalas na ginagamit sa ilalim ng mga sahig at sa ilalim ng mga kagamitan para mabawasan yung pagbabibrate mula sa materials patungo sa structure. And ito ay isang halimbawa ng hindi napagpatuloy na construction na kung saan daw kung pinagpatuloy ay mas magiging kagamit-gamit at mas ma-effective yon. So, vibration noises from equipment are also transmitted through pipes, ducts, or other similar conductors. Providing a break where they leave the equipment may reduce the transmission of noise from the equipment. Ducts and certain types of pipes may be isolated with flexible couplings and resilient connection na makikita natin mamaya sa figure 23.8. Water pipes should be provided with expansion valves, expansion tanks, and air chambers throughout the system to reduce water hammering and knocking. Noises from expansion and contraction of water pipes, usually a creaking and groaning sound, can be controlled by installing expansion joints in the line. So, nalilipat din daw to sa pamamagitan ng mga tubo, ducts, or yung other similar na mga conductor nga. And it's provide a break kung saan sila iniiwan yung mga kagamitan ay maaring mas mabawasan ang ingay mula sa mga yon. And ang duct ay ilang uri ng mga tubo ay maaari nga daw ihiwalay naman kakayahan umangkop sa pagkakakabit. So, yung mga tubo naman should provide with expansion valves para mabawasan yung water. And yung noises naman ay maaaring kontrolin sa pamamagitan ng pag-install ng mga expansion joints in the line. So, dito sa figure 23.8, makikita natin yung vibration noise from equipment can be prevented. So, in this letter A, makikita natin yung arrow, it is below also on return air duct. So, yung nasa may baba, it is the resilient pad. So, dito naman sa letter B, yung tubo na yun yung air chamber. And the air in chamber acts as cushion or shock absorber and absorbs pressure surge from the quick closing of the water valves. And lastly, dito sa last figure, makikita natin dito yung bellows, and this one is resilient mounting. So, next is isolation of impact. Impact sound is the sound caused when an object strikes another. Typical example of impact sounds are footsteps, falling objects such as shoes, toys, and machine parts, and hammering. When a structure is rigid and continuous, the sounds easily travels through it. Impact noise is controlled most effectively by using absorptive materials such as carpeting. By isolating the noise source using discontinuous construction and by reducing flanking, the introduction of masking or background should also be considered, but its effectiveness is limited when the sound to be covered over the loud. So, yung impact sound ay yung tunog na sanhi daw kapag ang isang bagay ay umaabot sa isa pang bagay. So, yung mga example nga nun, yung pagka may mga nalalaglag na object sa floor, yung sounds nun, yung impact ng sounds nun. Kapag ang isang structure ay matibay at tuloy-tuloy yung tunog ay mas madali siyang mag-travel sa pamamagitan nun. Impact noise is controlled most effectively by using absorptive materials. So, Yung masking nga daw or background sound ay dapat ding isaalang-alang, ngunit ang pagiging epektibo nito ay mas limitado kapag ang tunog na natatakpan ay mas malakas. So, kanina nabanggit natin yung absorptive material. So, hindi to kasama sa reference pero nilagay ko na din para magkaroon kayo ng idea. So, ito yung mga example ng mga the sound absorption material. So, ito nga acoustic glass, mineral wool, and etc. Pero ang ginagamit daw dito sa natin, most effective daw yung carpeting. So, yung carpeting kasi, it is effective sound absorber because the individual fibers, file stops, and underlay have different resonant frequency at which they absorb sound. So, isolation may be accomplished by separating the surface that will receive the impact from the structure supporting it. Floors may be isolated from the structure by using resilient subflooring and underlayment materials. Walls in figure 23.9, a variety of methods can be used to isolate sound transmission through solid structural assemblies may be isolated from the structure by mounting the finished materials or resilient channels. The ceiling and walls in the surrounding space may also be mounted or resilient channels carpeting with a thick pad below in one of the best absorptive materials in terms of reducing impact noise. So, ang mga sahig daw ay maaaring ihiwalay mula sa structure sa pamamagitan ng mga subflooring and underlayment na materials. Yung carpeting ay may makapal na pad siya sa ibaba nito, and ito daw yung isa sa pinakamahusay na material na sumisipsip nga sa mga tuntunin na pagbabawas ng para mabawasan yung ingay. So, dito sa figure 23.9, makikita natin yung variety of methods na pwede natin gamitin sa pag-isolate ng sound transmission through sa solid structure assemblies. So, ayan sila. And dito sa last.
So hello everyone, this is Brizali Pachag reporting, and my topics are isolation of sound, sound masking, and active noise control or ANC. So isolation of sound. The amount of the airborne sound transmitted between rooms will depend on the material and the methods used in the construction. Sound transmission through wall depend on the mass or unit weight of the walls and their inelasticity. So, depende pala yung soundproofing ng kwarto sa mass ng isang bagay, ng isang wall from one room to another. So, kadalasan ginagamit nating material sa soundproofing is lead dahil maganda siya for isolating sound. Massive thick walls provide excellent sound barriers, but economically there is a point of diminishing returns. So, hindi porket kapal yung walls mo, ibig sabihin soundproof na yung kwarto. As the mass is doubled, the transmission sound will be reduced by 6 dBA. Therefore, the mass alone is not economical solution for isolating the sound. Building frame walls with staggered studs and with blanket sound insulation between outer walls surfaces is a good method of sound control. So, ano nga ba yung staggered studs? So, ito yung this base and top plates of the wall should be of 2x-inch boards and instead of regular 2x4s. So, ito yung way ng pagkakaroon ng frame ng kahoy depending on the situation. So, blanket sound insulation naman is ito yung ginagamit to cover up walls to also help the insulation of the sound. So slightly more effective is the building of 2 separate walls with no structural connections between them. So ito yung, for example, yung floors that can be isolated from the structure by using resilient subflooring and underlayment materials. So, as we can see in this picture, nasa baba yung resilient pad with supporting wood sleepers. Tapos, dun pa lang yung floor and room. So, wall covering surface thus dissipating sound energy in the channels. This method is also have practical limitation for a specific mass. As the airspace doubles, the transmission of the sound is reduced by 5 dBA. So, a flanking sound transmission path that bypasses the transmission barrier. It is a route which the sound may easily travel through wall or assembly. So, ito yung example ng frame walls with staggered studs and with blanket sound insulation between the outer wall space, surfaces, and in good method of sound control. So, makikita natin sa baba, nandun yung staggered wall with insulation of STC50, tapos meron pa siyang 2 inches insulation. And as we can see here, meron din siyang 1/2 gypsum board and caulk. So, doon natin ma-assure na ang isang wall is talaga namang soundproof dahil gumamit niya siya ng ganong technique. So, opening doors, windows, and electrical outlets create good flanking sound paths. Rigidly connected electrical conduit. Airborne sounds passing through the flanking path can significantly diminish the assembly sound isolation capability. For example, meron tayong 1/4 in perimeter crack surrounding ng 96 feet squared partition system represents as approximately L2 feet squared opening. In terms of sound rating, this untreated perimeter crack will reduce overall performance from 53 STC to 29 STC. Examples of contraction techniques are shown in this photo. So, ayan. The weak point of the sound insulation in the building envelope is frequently the windows and doors. So, alam naman natin na ang pinaka talagang weak point ng isang walls is ang windows and doors dahil doon wala namang soundproof na pinto or windows. So, double glazing would afford noticeably better protection than single glazing. In areas with high external noise, it might be preferable to have double windows, such with large air gap, 1 to 4 inches, 24 to 100 mm. So, kapag maingay talaga yung lugar, mas magandang suggestion is magkaroon ka ng double windows with large air gap. And acoustic absorbent materials on the perimeter are built around the gap. Doors will also typically represent the surgeon's weakness in the good wall. So, insulation ratings of the solid core doors may vary from STC 15 for swinging door with clearance all around STC 27 for the same door completely sealed by gaskets or weather stripping all around. So, kapag magkakaroon tayo ng soundproof na kwarto, sisiguraduhin din natin na magkakaroon naman ng kahit kaunting soundproofing yung walls and windows natin. Kasi diba, nonsense naman kung ang room mo is soundproof, pero pag may tao sa labas, maririnig niya through windows or doors. Especially lalo na kung ang isang door is hindi ganun kalapat, doon talaga magkakaroon ng sound leaking. A more typical installation with stops from 3 sides but no gasket about STC 20. In commercial buildings, ito yung picture, a common sound insulation problem exists where wall partition terminate at the suspended. So, ito yung example ng slatted acoustical concrete masonry units dumping sound, thus improving the noise reduction attributes in interior space. So, makikita naman natin. Kapag ganyan ang masonry units mo, talaga ma-reduce nyo yung sounds and other positives from internal acoustics. So, for the next picture, so ito naman yung example ng sealed openings to prevent playing sound from bathroom above. So, kung makikita natin, parang meron siyang bara dun sa taas kung saan doon natin mape-prevent yung pagkakaroon ng sound leaking dun sa bathroom kasi yung taas niyan bathroom. So, ayan yung mga tubo pababa. So, the ceiling level with such a system, sound can be transmitted up through the suspended ceiling from the plenum space. Through the plenum above the partition of the down of the other side, extending the wall to the bottom side of the floor, eliminates this problem. But is more costly and offer less flexibility with future renovations. So the practical economical limit of the sound reduction through walls about 50 dBA with the use of background masking noises. This reduction is adequate for the most conditions. At the time, great care should be take to eliminate as much as sound transmission as possible through flanking paths. Air ducts, soffits, and item placed back to back, such as medicine cabinets, electrical outlets, and lighting fixtures, sound transmission through doors and door arrangement, and through window and window arrangement must also be carefully considered in achieving noise control. So, kapag magsa-soundproof tayo ng isang room, kailangan sinisigurado natin na walang leakage ng sound na magkakaroon sa isang room. Kailangan i-seal natin yon. For example, dito nga sa picture makikita natin, meron bara yung pinaka-tubo. So, kasi kung walang ganyan yan, syempre maglilik din yung noise, di ba? So, sound masking. Sound masking, ano nga ba yung sound masking? So, sound masking is the addition of natural or artificial sounds of different frequency into environment to mask or cover up noise. Sound masking reduces or eliminates awareness of existing noise in specific area. So, sa sound masking, doon natin nababawasan yung different frequency. Halimbawa, yung isang room is talagang maingay, doon na tayo gagamit ng sound masking. It can make work environment more comfortable and more productive by creating speech privacy and making workers less distracted. So, usually, ginagamit to sa mga buildings with workers or workplace office. Kasi, pagka ganun yung lugar, kailangan talaga ng privacy ng workers para din maging productive sila sa work. Kasi 'di ba, for example, ang calls na tinatanggap nila is private calls or calls na kailangan ng privacy. So, doon na tayo papasok sa sound masking or soundproofing ng isa kwarto or ng lugar. An effective method of sound masking is to introduce background sound within the room. White noise, so ano ba yon? Is a type of background noise that is produced by combining sounds of all different frequencies together into an intangible sound may be introduced into the space. Because white noise contains all frequencies, it is frequently used to mask other sounds. So, itong white noise, ito yung type ng noise na ginagamit natin to mask other sounds na hindi naman essential dun sa isang lugar. So, illustrates a typical example of effect of background sound and masking undesirable noises. Masking sound includes pipe music, radios, or even the humdrum white noise by hitting the air conditioning systems in the building. Some manufacturers provide white noise sound machines to white noise generators with blowers, and most heating cooking units can provide background noise capable of masking many of the noises in the building. So, ang example lang nitong white noise is yung background music. So, for example, di ba sa mall, dahil nga maingay yung lugar, nagkakaroon sila ng white noise to distract the consumers para din hindi nila gaanong hindi sila gaanong ma-distract dun sa sound na napoproduce ng dami ng tao. So, halimbawa ng isang lugar na walang white noise is yung palengke. So, di ba, dinig na dinig mo lahat ng chismisan, lahat ng ingay ng mga tindera, ng mga bumibili. Kasi nga, walang background music. Hindi kagaya sa mall na mas relax yung mga bumibili kasi nga, mas magkakaroon sila ng focus doon sa kanta kaysa doon sa ingay ng mga tao. So, although many blowers are set to automatically shut off when the thermostat does not call for heating or cooling, it is sometimes effective to have these blowers run all of the time to provide both background noise and air circulation. Many stores and restaurants use pipe music to mask the noise from people working, traffic passing, and multiple conversations. Background sounds are often introduced to a very quiet dead rooms. So also gumagamit din tayo ng background music kapag yung lugar is talagang tahimik kasi 'di ba? Doon pumapasok yung kapag sobrang tahimik ng lugar, parang nakakabingi din. So, yun nga, for example, our sleeping areas in nursing or rest homes or in residence to busy streets would be disturbing. It is also provides some privacy for speaking and telephone communication. So, 'di ba, kapag may background music, halimbawa, yung nasa labas, hindi nila ganun maririnig yung usapan sa loob kung may background music sa loob. So, doon pumapasok yung sound masking. Acceptable levels of background noise range from 25 to 35 dBA in bedrooms. So, ito naman yung mga range ng background music. Background noise, And in living rooms naman, ang background noise na nagre-range is only 30 to 40 decibels. Offices and conference rooms, and 35 to 45 in large offices, reception areas, and secretarial areas. When acceptable levels of background sound is combined with effective transmission of ratings of the walls, it is possible to tolerate relatively high surrounding noise levels. So, next is, ito yung picture na makikita mo yung effective method of reducing the awareness of unwanted sound to use background noise within the room. This is sound masking. So, halimbawa, makikita mo dito ang room na merong 85 decibel sound and 50 decibel sound. Bakit mas mahina doon sa kabila? Kasi gumamit na tayo ng soundproofing doon sa gitnang part ng room. So, habang lumalayo yung sound papunta sa BR sa dalawang sides, mas humihina yung sound kasi itong mga walls na to is meron nating soundproofing. So, dito naman, sound inaudible, the level of sound must be brought at least 10 decibels below the background noise to make it inaudible. So, as we can see, ito yung type ng wall na ginagamit to sound mask or to soundproof a room. So, next is active noise control. So, ito na yung last topic ko. Active noise control, also known as ANC, or active noise reduction, or ANR, or anti-noise, is a method of reducing unwanted sound through sound energy cancellation. In the simplest form, a one-dimensional ANC system uses microphone connected to electronic circuitry that recognizes the unwanted sound and the speaker that generates the anti-noise sound wave, resulting in the destructive interference, which cancel the noise. A three-dimensional ANC system requires microphones and speakers. Each of the speakers tend to interfere with the nearby speaker, reducing the system's overall performance. Particularly where there are multiple listeners, another type of noise-canceling technology involves treating glass with small squares of piezoelectric materials and measures from counter-vibrate the glass to cancel transmission entirely. So, in this picture, papakita ko lang dito kung paano gumagana yung active noise control. So, makikita natin kung nandito yung ingay natin sa noise source at lalabas siya sa primary noise. At makikita natin yung error microphone dito kung saan magkakaroon ng active noise control. So, ang pinakamagandang example dito is yung noise cancelling earphones. So, 'di ba, ginagamit natin yung noise cancelling earphones para ma-mask yung sound sa labas papunta sa tenga mo. So, dahil doon nagkakaroon ng speaker sa loob para hindi mo marinig yung tunog sa labas. So, ito yung example ng noise cancelling headphones. Wait. So, as we can see, ito yung headphones. So, magkakaroon ka ng primary path sa labas. Tapos, sa loob yung secondary path kung saan nandun na yung pinaka-speaker mo. At pagdating na sa tenga mo is hindi mo na maririnig yung ingay sa labas. So, maganda to for workers na tumatanggap ng calls, for example. Kasi mas magkakaroon ng focus yung worker dun sa kausap niya lang. And also, mas maganda to generate the focus ng isang worker. So, that's all for today. Thank you for listening.